Good morning, everybody. So this is Dr. Dinesh of Government First Aid College and PG Center, Chintamani. Today we are going to study about the transistor chapter for B.Sc students of Bangalore North University who are all studying in final year 5th SEM in the subject physics of the paper 503. Here we are going to deal about the third unit, that is semiconductor physics. In this semiconductor physics we are going to study the third chapter for B.Sc students. Before starting about transistors, first we should know something, the history of transistors. A first transistor, you can see to the right corner of the screen, this is a transistor which has been first invented. It is a replica actually. It's a replica of a first invented transistor which has been invented by John Bardeen and Walter and Shockley in 1947. Has been invented in Bell Laboratories of United States of America. And this transistor invention is a huge relief for energy and also for space, and which has been considered a most significant invention of the century or in the 20th century. And we're going to study something, the basics of a transistor, which is mostly related to the transistor action and its characteristics in case of a common emitter mode. And here the prerequisites. A student should understand what is the basics of a semiconductors. So there are two types of semiconductors, intrinsic and extrinsic semiconductors. Extrinsic semiconductors again classified as n p-type semiconductor and n-type semiconductors. And a trivalent impurity is added to a pure semiconductor considered to be p semiconductor, and a pentavalent has been added to a pure semiconductor gives you an n type of an extrinsic semiconductors. One could be an acceptor impurities and another could be an donor impurities should be added to a semiconductor in order to get an p-type and n-type semiconductor. And when these p and n type of semiconductors are joined together, it can form a p-n junction. And this p-n junction, when it is connected to a external voltage source, if p is connected to a p region, positive of a battery, and n of a junction, p-n junction has connected to n negative of a battery, it is said to be under forward biased condition. In the other case, it will be a reverse biased conditions. What are the characteristics? What are the characteristics of a p-n junction? One should understand, which is a prerequisite for any student before understanding about a transistor. And also that student should have an idea about the majority charge carriers and a minority charge carriers. So in case of a p-type semiconductor, the holes are the majority charge carriers and electrons are the minority charge carriers. The majority charge carriers are coming from the impurities which have been added to a pure semiconductor material. And acceptor semiconductors are considered to be a p-type of impurities which have been added to a semiconductors. In case of an acceptor impurities, one could have a trivalent impurities. A trivalent impurities are example for these are indium, gallium, aluminium, boron, etc. are an acceptor impurities which are having a trivalence at their outermost shells, or three valence electrons they carry. And in case of in pentavalent impurities or donor impurities, you can call one extra electron will be there when it is bonding with an tetravalent silicon material, which are considered to be a pentavalent impurities. Example for this is phosphorus, arsenic, and antimony are most commonly used pentavalent impurities. But also the creation of an electron hole pair, when an external energy which has been supplied to a p-n junction, there is a creation of electron and hole pairs. There is a breaking of a bond which creates an electron and also a hole pairs, how it has been created and all, which one should understand initially. And after this session, what you are going to learn, which is very, very important. After this class, what we are going to study, what we are carrying after this class to the future. Now, a student should understand about the type of charge carriers. There are two types of charge carriers, we know that. One is electrons and holes. And also the different types of transistors which are there. There are two types of transistors which are considered to be an NPN transistor and a PNP transistor, and their circuit symbols. A symbolic representation is, general representation is different from the circuit symbol. One should understand the circuit symbol of an NPN and also PNP transistor should know. A student should know about difference between an NPN and PNP transistor circuit symbols and different regions of a transistor. This is for the construction of a transistor one should understand. Like there will be three regions most commonly, that is emitter region, base region and collector region. What is the basic difference between these three regions that a student should understand, and also its construction. So how a transistor has been constructed with this, how these donor impurities or an acceptor impurities are added in order to get an PNP or in order to get an NPN transistor, and especially when you can make the transistor as an emitter region, how can you make a base region and also a collector region is also important. And a transistor biasing is again important. It is unlike an PN junction is getting biased, a transistor should also get biased in the two ways, that is the forward biasing and also reverse biasing. When a transistor is biased under a suitable condition, so there are junctions, one particular junction is said to be under forward and another one is under reverse biased condition, the process of amplification could be taken place for a transistor, and that leads to the production of a particular current at three different regions. A current which is coming out from an emitter region considered to be, it will constitute an emitter current, and a current which is coming out of a base considered to be a base current, and across a collector it is considered to be a collector current. So these are the three different kinds of the currents. And here coming to these are all a student after this session he should understand, and he should carry this information to home. And an introduction to the transistor. So before going to study about a transistor, unlike a PN diodes, these transistors are a most popular semiconductor devices. And example for these transistors are bipolar junction transistors. There are different types of transistors you can see. Among that, very important one is bipolar junction transistors. We are going to deal for this session. What is a transistor? A transistor is a three-terminal, two-junction electronic device which is generally made up of a pure silicon and germanium materials which are doped with an trivalent impurities and also a pentavalent impurities. In order to get a P type of silicon or germanium or N type of silicon or germanium, one should add these impurities. And these transistors are often said to be most significant innovation of a 20th century. In the 20th century, a lot of innovations have been taken place. Innovation of a laser has been taken place, or an atomic energy has been invented. A lot of other inventions. The one prime invention is a transistor, which has replaced all vacuum tubes, whose efficiency has been increased, space has been reduced, and a lot of other advantages can be seen from a transistor. A transistor is a basic component for all type of an IC, integrated circuits, and transistors are building blocks of digital revolution. When a transistor is under off condition, it is considered to be a zeroth state of an what you call digital electronics. When a transistor is said to be in on condition or in voltage is high, it is said to be under on or in one condition. So you can make in zeros and ones, therefore digitalization will coming into existence. As a result of this transistor, or a result of this digital revolution, the computers are invented, mobiles have been invented, or calculators have been invented. These are all the special advantages of a semiconductor devices, the transistors. Specifically, the transistors are very complex because how they are used, they will act like that. Hence, they are most complex and can be used in a many ways, as by making an emitter as a common, by making a base as a common, collector as a common. It can be used for huge applications, like a switch you can use, like an amplifier you can use. That is the main important feature of a transistor. And amplification can be, what do you mean by amplification? The amplification is that if you feed an input signal, that will get amplified. That means this is the input voltage, you can consider the vertical line, and here from here to here, this is the output voltage, you can call a amplification. Amplification has been done, and also there is an inversion has been done. When you are feeding an input signal, there is an input signal is in the positive half, the output will be of an 180-degree phase shift has taken place. This is again an amplification for the case of common emitter amplifications. So you are getting an voltage gain, the voltage will get enhanced, the current will get enhanced, and it will get inverted. So inversion is also quite important, because when the electrical signals are you are feeding into that, you should get an some other signals, it should get inversion. It could also be converted into a voice, something like that. And a transistor as a switch, you can see this is a symbolic representation of a transistor. I will tell you later. It can be used like a switch. So the collector and emitter region can act like an on and off condition by maintaining a suitable current across a base. That means for the base you are giving a positive, if you are having a control on a current across a base region, you can have an across a collector, you can have a control on the output. That means if sometimes it can be acting like a 1, sometimes it can be acting like a zeros. As a result, you can see that there is an on and off conditions. It can be obtained by an load line analysis. So in a load line analysis also, you can come to know how the transistor will act like a switch, and also act like an amplifier. So these are all the amplification. Can be amplification means making a weak signal into strong, like the sound waves which are there, the weak sound signals can get amplified. Here also I'm using this amplifier. You can see this is an amplifier. My small signals can be amplified by using a microphone. It is getting converted. I'm using this transistor. In other words, I'm using this digital world. And in general purpose function of a transistor is gain. What do you mean by gain? You have if you are giving a small amount of current into that transistor, the current will get enhanced by some phenomenon. We don't know what is the phenomenon. Something is happening inside the transistor. Because of that, the current will get increased. So by feeding a small current, you are getting a large current, or by applying a small voltage, the voltage will get enhanced. So voltage amplification or current amplification. So one can call it as an voltage gain, and also there could be a current gain. So the ratio of output to the input is considered to be a gain. And the secret is that how this gain is producing inside a transistor, one should understand with the help of this session. After this session, you should be able to answer how this secret has been taken place. Now coming to the introduction to bipolar junction transistors. A bipolar junction transistor, I said, why this word bipolar, two poles. So a BJT, is bipolar because it has both the holes and electrons will be a charge carriers. That means the current flow is because of both type of charges, that is electrons and also holes will make these devices. So the holes are considered to be the holes are considered to be positive type, or that is considered to be an N type. The N type region consists of a free electrons which are considered to be a negative charge carriers, and a P type region is considered to be a P region, or a hole region, or is also called as a positive carriers. The two type of BJTs, bipolar junction transistors, which are NPN transistors and PNP transistors. What is an NPN transistors? N means negative, P means positive, again N means negative. A P type of semiconductor has been sandwiched between the two N type of semiconductors so that there is a formation of NPN. A P type has sandwiched between the two N type of semiconductors so that you will get an NPN transistors. So there is an NP junction and PN junction. So in an NPN transistor, there will be two junctions have been formed. These junctions are also called as depletion layers. So there is an NP and also PN junction will be there. Similar to NPN, there will be another transistor which is called as an PNP transistor. So here the mentioning is should have another name, that is a PNP transistor. And here the transistor regions, in the case of an NPN transistor or PNP transistor, there will be three regions. They are considered to be transistor regions. So first one is called as an emitter region. Here an emitter is one, it will send a charge carriers into a base region, and then they will carry to a collector region. So they will carry to the collector region. That is considered to be an emitter. What is a base? A base B acts as a control region. So like if I have a pipe-like structure, the water is coming inside. It is considered to be an emitter. The charges are carrying into the tap. And here on the tap there will be a control called as a tap controller. What you can rotate that. By rotating that, how much number of electrons can flow out of this pipe can be controlled. So the number of electrons which are moving out are considered to be a collector carriers, or a collector current you can call. And the collector which will collect the carriers. At the case of a base region, it can have a control on them. A part of the incoming charge carriers could remove, a limited amount of charges can be moved to a collector. Hence, it can be act like a control region. It can allow some, it cannot allow any charges. It can allow none or some or many charge carriers. As many charge carriers which are coming in, so much of charge carriers can flow to a collector. So like that, a base can act like a controller of a charges. In other words, it is a controller of a current you can call. And an NPN and PNP transistor, how it has been constructed, or a structure, you can see this is an emitter, base and collector of a PNP transistor. So an N region has been sandwiched between the two P regions of a 2p region, so that there is a formation of an PNP region, and this is called as a PNP transistor. Here this P region is considered to be emitter, which is heavily doped. The doping concentrations and adding of an trivalent impurities like indium or gallium or aluminum, and trivalent impurities which are added to an emitter is the concentration is very large. Maybe 10 power 18 impurities, 10 power 18 of an aluminum atoms into an pure silicon material which can form a P type of semiconductor. And there is an a lightly doped N region, very lightly doped phosphorus. For a pure silicon, you can get an N region, and also it is very very thin, which constitute a base. And why is this one? Because of recombination. Some amount of recombination has to take place. You have to stop a current. For how can you stop that? By applying a recombination, by removing the charge carriers. How do you remove that? By recombining, which are the opposite type of charge carriers. By recombining them, you can control the large number of charges which are flowing to a collector. And its thickness is very very thin. There is another one which is called as a collector. Its area will be very large, but it is moderately doped with a p type of impurities, with an acceptor impurities or a trivalent impurities, like you can call a aluminum or boron or gallium, indium, anything. So most popularly used are boron or aluminum will be used. Indium, gallium are costly, but they are also applied. And this is an PNP transistor. It is having a construction or a structure, and this is an a mechanical structure. Let us see what is in the circuit symbol or a symbolic representations. There is a circle inside that. If you are putting a line something like this, and this is called as a base, and this is a collector, and this is an emitter. Across the emitter there is an arrow region has been indicated. This arrow indicates a direction of flow of charges from outside towards this junction, that it is moving. The charge carriers will move. That arrow indicates the direction of flow of charges. Here the current which flows across a base considered to be a base current. Current flows across a collector considered to be a collector current denoted by IC, and current which flows inside the arrows indicates a direction of flow of current. The arrows indicate there is an emitter current. So you see that across a base the current is denoted by microampere, 10 power minus 6 ampere. Very very small amount of current will flow through a base, still it acts like a controller of current. And this is in collector current. It flows all the current from base and emitter, it will getting collected across here. Sorry. And you see that this is a milliampere current and this is a milliampere current. 10 power 3 times, 1000 times more current will flow across an emitter and also across a collector. And this is something about a PNP transistor. And also you should NPN transistor also, it is likely same. Only the difference is that direction of flow of current and also the direction of indication of arrow. Here the majority charge carriers are holes which have been indicated in this direction. Here the majority charge carriers are electrons, hence this has been denoted by like this. You can see the collector current and base current will flow and it is moving towards an emitter. It shows the direction of flow of majority charge carriers. And this is an NPN transistor. How do you get this NPN transistor? A p-type semiconductor has been sandwiched between two n-type of semiconductors so that an NPN has been formed. NPN structure has been formed, which is called as an NPN transistor. And this is having an NP junction and PN junction. There are two junctions are there, hence the name bipolar or an two junction, bipolar junction transistors, hence the name BJT, bipolar junction transistors, which is having two junctions. This is a collector, base and emitter. This is an physical representation of a transistor, and circuit representation is this one. Now, this is something about the construction of a transistor. As I said that the transistor has been constructed of in three doped regions. I did not mention that how the doping will take place in case of an emitter, base, and also a collector. Both NPN and P-type transistors are having a very narrow region sandwiched between a larger collector regions and emitter regions. Collector and emitter regions ಅಲ್ಲಿ ಡೋಪ್ ಮಾಡಿದ್ರೆ, if you are placed in between two N type of semiconductors or two P type of semiconductors, opposite type of semiconductor has been sandwiched, which forms an NPN or PNP transistor. Now coming into a construction. So this diagram, what it is there, it will shows that the doping concentration of an impurities. Here the impurities are negative type of impurities, or these are called as a donor impurities. Example, a phosphorus. A phosphorus has been added to a collector region. In case of an emitter, again a phosphorus has been added. It is a pentavalent extra electron it is having, which is called as a donor. And you can see both of them are donors, but number of negatives which are placed is different. It is heavily doped. Heavily doped means adding large number of negative charges, or large number of phosphorus or antimony or donor impurities are added to this type of semiconductor, so that it forms an emitter, and its thickness is moderate. Whereas base is having a positive, a very thin and lightly doped region forms a base, and moderately doped and larger area of cross section, which is considered to be a collector. So emitter is a heavily doped, and its job is to impinge the carriers into the base region. It will gives a huge amount of charge carriers. How many number of current which is coming from a collector, which are all given from this emitter. Hence it has to be heavily doped, and the base region is a very thin and lightly doped, a thin region, and most of the current carriers injected into base region pass into a collector. Here this is of an opposite type, and it is very thin, the charges are very less, therefore among the most of the current which has been passed through the base, a part of these positive charge carriers are undergoing a recombination. A plus and a minus will join together, so that it will form a recombined or a neutralized. The current will get neutralized or it get controlled. How many number of current, by depending on the number of current which is passed through a base, you can control a current across a collector. The collector region is moderately doped and is largest of all three regions. Why this has to be larger? Because it has to collect all the current which is coming from base, so that its area should be large, so that less heat will get produced across that. There is no heat practically. And transistor configurations. So the transistor configurations, there are because in a transistor, which is a 3-terminal device, and this should invented for a particular purpose. For any purpose, one should have an input and one should get an output. For input, one needs a 2-terminal. For output, again one needs a 2 terminals. Totally 4 terminals are needed to get input and output. To make an input and to get an output. But here only 3 terminals are there. Therefore, I can use any one terminal as a common for both input and output. So here you have an emitter, base, and collector. That means I can make a common emitter, common base, and common collector. Based on this type of arrangement, you can have a configuration of 3 types in case of a transistors, which are considered to be 3 type of configurations. One is common base, common emitter, common collector. Here the base has been common for both input and also an output across a transistor. Here is a transistor, and here is an input, and this is the output. So they're all common there. And in case of a common emitter, so for a common emitter, there is an emitter is a common for both input and also an output. And also in case of a collector, one is common is collector region is common for both input and output. Based on this, the transistor configuration is a connection of transistors to get a variety of operations. For different operations, different connections have been made. Hence, transistor is a very complex device. It can be used in many ways for many applications. So, what are the some of the features of a particular configuration? So, coming into the common collector configuration, here the common collector configuration, the input signal is applied to the base. So here you are giving an input signal across the base terminal, you are giving an input signal, and output signal is taken across an emitter terminal. So here the collector is common, hence you are giving an input to the base, you are taking an output at a emitter. And the collector terminal is common to both input and output of the circuit. So here BC is an input, the CE is an output you can take in this particular configuration. And there is another one which is called as a common base. So the base terminal is common point for input and output. So the input is emitter base junction, the output is collector base junction. And the amplification, the not applicable as an amplifier. The common base configuration cannot be applicable as an amplifier because the relation between input current gain IB and the output current gain is approximately 1. How much current you are giving, so much only you are getting the current across the collector. Hence, this cannot be considered as an amplifier. So the next configuration is common emitter configuration. In case of a common emitter configuration, the emitter terminal is common for input and output. This is an emitter terminal common for both input and also an output. Here input is base emitter terminal, output is collector emitter terminal. The mostly applied in practical amplifiers. For all amplification circuits, this is common emitter amplification has been used. Why? Because it provides a very good voltage, current, and also a power gain. Power will get increases, voltage will get increases, or current will get increases. And based on this, there will be in multiple choice questions you could answer later. Coming into the biasing of a transistor. What do you mean by biasing? So as I said that a transistor is having two junctions. First let us bias one junction. Let's take an example of an base collector junction. Here the collector is of negative type, the base is of positive type. The positive has been connected to a negative of a battery, and the negative type of a junction has been connected for a positive of a battery. It is said to be under reverse bias condition. Because of reverse bias, the depletion region will get enhanced. Because of increased depletion region, the resistance offered for the flow of current is large, hence there is no current will get absorbed. Whatever the current you are getting, it is because of minority charge carriers only. So this is the reverse biasing of a collector based junction. Now let us see something to the other junction when it is said to be under forward biased condition. You see that as I said that the base is having an P region and the emitter is having an N region. Emitter is an heavily doped, base is lightly doped, and this is connected for an external battery. When positive region has been connected for positive of a battery, negative region has been connected for a negative of a battery, you can see in a the current meter, or in an ammeter, there will be a large amount of current is flowing here, because the external voltage what it has been connected will drive the current. So positive positive, negative negative, across a junction there is a repulsion. Because of repulsion, the depletion width will get reduced. The width of depletion is larger, larger will be resistance. The width of depletion region is lesser, lesser will be the resistance for the flow of current. Because of less resistance, the current flow is large, hence the ammeter reads a very huge current. The current will be very large, and this is because of forward biasing of a junction. What is forward biasing? Positive is connected for P region and negative of a battery is connected for N region of a transistor, so that this junction is said to be under forward biased condition. Under forward biased condition, large amount of current will be flown through the circuit. And let's take an example. Two situations are taken together. What is the two situation? The collector based junction. The collector based junction is also be biased, and also the emitter based junction is also getting biased. How it is getting biased? The collector based junction has been connected in a reverse biased condition. What do you mean by reverse bias? Positive of a battery is connected for a negative region of a transistor, and negative of a battery has been connected for a positive region of a transistor. This loop or this circuit is said to be under reverse biased condition. Coming to the other loop, or coming to the other junction. What is that junction? Base emitter junction. Across this base emitter junction, the positive region has been connected for positive of a battery, negative region of a transistor has connected for a negative of a battery. This junction is said to be under forward biased condition. Because of forward biasing, depletion width is very large, huge amount of current will flows. That means whatever the current which is coming from a from the emitter, all that current will flows through a collector region. So this will be very less and this will be very huge. You can see here, you can see the beauty of this connection. What is that beauty? So this region will leads to a large current flow, hence the meter will reads a larger here. And one significance is that here the collector current reads a maximum current and emitter current reads a maximum current, base current reads a very low current. And another trick, as I said, that what is the trick? The collector base junction is said to be under reverse biased condition, even though the collector current is very huge. Coming to the earlier case, there is no current here. The current is very low. Though it is under reverse biased condition, current is low, and now you see the magic. But under reverse bias condition, this is having a large current. What is happening here? What is happening here? It is happening that across the base region, base plays a prime role here. It is a controller of current. By moving a small current, by applying a small current, by opening that, large amount of water can flow through a tap. Like that, large amount of current can flow from emitter to a current, collector current. Hence you are getting a collector current is very, very large by applying a small base voltage. This is the secret behind the amplification. And here notice that when IB is very small, IE and IC are very, very large. And when here you can see that when there is no current flows across here, you see that when just in earlier there was a small current across a base. Now there is no current, it just open. That means the base current is 0. When IB is 0, you can see that there is no current across a collector, there is no current across an emitter. Both the other criteria are all same. Only thing is it is just opened. So because of this, the base acts like a controller of current. There is no current. across a collector. There is no current across an emitter. Though there is a doping regions are there, but based on the IB base current will act like a current controller of a transistor. This is very important. And by applying a suitable very small current, for example at 1 milliampere, you can get a collector current of an 99 milliamperes. And here the total current of an emitter is that 100 milliampere. This 100 milliampere is in donating charge carriers you are giving. So it is in diffusing charges are 100 milliampere. In that one milliampere is getting recombined across a base. Remaining 99 milliampere current, whatever it is coming from an emitter region, it will be given to a collector region. Hence that reads an 99 milliampere. And what is a gain? Gain is nothing but the input to the output ratio. The output is 99 and input is 1 milliampere. The ratio is 99, which is called as a current gain. Common emitter current gain. What is that, sir? The input current is 100 milliampere, right? No, it is not like that. The input is ratio of output to the input. Here the input is base current and output is collector current. That's what the transistor is a complex structure. We should understand more about a transistor. And coming to the Kirchhoff's voltage law, if it is applied across in Kirchhoff's not voltage law, Kirchhoff's current law. So current law says that across any node, algebraic sum of currents entering into a node is equal to the algebraic sum of currents which are leaving out of that node. Which are the currents which are entering? The entering current is IE. So algebraic sum here, the currents which are coming out. So this is the current which is going in, and IB and IC. So the sum of IB is 1 milliampere, this is IB, and IC, that is 99. 1 plus 99 is 100 milliampere. This is Kirchhoff's current law, which can be applied to a transistor. So in an PNP transistor, so what I have studied is an NPN transistor. Coming to the PNP. PNP means the negative region or an N region has been sandwiched between the two P regions. Here heavily doped with a P region, lightly doped with N region, moderately doped with the P region constitute a collector, base and emitter. And now the other operations are all same. Here the holes are the majority charge carriers. Whatever the current you are getting, it is because of holes here. And whatever the current which is getting here, it is because of the recombination current. Hence the base current can also be considered to be a recombination current. Number of negative charges which are combining with the positive, it will form a recombination. And here we should notice that the bias voltage is again which is very similar to an NPN transistor, but the charge carriers are holes. The holes flow from emitter to a collector region. And how this biasing is different from an NPN and PNP. So that is an NPN biasing or PNP biasing. The fundamental operation of both PNP transistor and NPN transistor all similar except only 3 points. What are that? The role of electrons and holes. Here the majority charge carriers are holes in case of PNP. In case of NPN, the majority charge carriers are electrons. And the voltage bias polarity, you can see that polarity will get reversed. Here there is an emitter, base and collector. There is an emitter, base, collector. The polarity will get reversed. Only that polarity of the biasing will get reversed, and also the direction of current flow. Here the direction of current flow will get reversed. Except this, all operation of an PNP and NPN transistors are all same. Now at the end of this session, the students should be able to understand the significance of a transistor in day-to-day life, how it is important. One should understand how that current will comes here. Hence, you should know that what is the structure of bipolar junction transistor. The structure of bipolar junction transistor is that there will be emitter, base and collector. The doping concentrations of emitter is huge. Doping concentrations of a base is very light. Doping concentration of a collector is moderate. And the structure, that is the thickness of an emitter is moderate. Thickness of base is very thin. Thickness of collector is very large. And type of charge carriers, there are two types of charge carriers. One is positive or p type charge carriers, and another one is a negative or n type of charge carriers. And transistor biasing, the transistor biasing is one can make an forward biasing and reverse biasing, or you can combine forward biaser junction and reverse biaser junction together in order to make an operation as an amplifier. Hence, it can be operated in by using three different regions. It can be operated in common emitter mode, common base mode, and common collector mode. So that can be the session outcomes of this session. Now let's go to the multiple choice questions. The multiple choice questions is that what is the number of depletion layers in a transistor? In a transistor, how many depletion layers are there? The depletion layers can also called as a PN junctions. So there are two PN junctions across any type of NPN and PNP transistors. In a BJT or bipolar junction transistor, there will be two regions are there. Therefore, two PN junctions, there are two depletion regions. The thickness of depletion layer will depend upon the biasing condition, how much of reverse bias voltage you are applying, how much of forward bias voltage that you are applying to the junction. That depends on the thickness of the depletion layer. Next, second question is that the base of a transistor is dash doped, whether it is heavily doped, moderately doped, or lightly doped, or it is not at all doped. The base of a transistor is a lightly doped. Why it should be lightly doped? The answer is here. The most of the transistors, the emitter is heavily doped because it has to give the charge carriers. It has to inject the charge carriers. Its job is to emit or inject electrons into the base. The base are lightly doped and very thin. Because of this, it has to pass most of the emitter injected electrons onto a collector. Only then it can give the charges to a collector. Hence, it has to be lightly doped. Also, its thickness should be very thin. And the third question is that a transistor is a dash operated device. A transistor is a current operated device or a voltage operated device, or both. It is current operated and voltage operated device, or none of this. It cannot be used for voltage or current, something else. The answer is this is in the most probable answer I can tell. It is a current operated device. Why? For a given emitter current, the collector current is controlled by a base current. Base current is a controller. Therefore, the change in the collector current is related with the base current and not with the base voltage change. Base current ಗೆ ಸಂಬಂಧಪಟ್ಟಿದೆ ಬಿಟ್ರೆ base voltage ಗಲ್ಲ. Hence, that's why the transistor is a current operating device. It's not a voltage operating device. It is a current operating device because the base current controls the current of a transistor, how much it has been flows across a collector. The next question is, most of the majority carriers from the emitter dash ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ? Most of the majority charge carriers from the emitter recombine in the base, combine in the emitter, or passes through the base region to the collector. None of the above. Most of the majority carriers from the emitter passes through the base region to the collector. Ide purpose. This is the purpose of a transistor. We should understand this. And the current across a emitter, which of this is correct? So you can see by applying a Kirchhoff's current law, IE which is equal to IC plus IB. This is how much number of current which is produced, which is equal to the current which is collected across a collector and also recombined across a base. Hence the answer is 4. And this is just an information to you for a basic level. You can study a lot more by using a prescribed textbook for you, that is Basaraj. There are other textbooks also, you can refer that. They are all quite easy and very good resource persons have written the textbooks, and many more textbooks are there. But for this material I have used this one, and Wikipedia I have used a part for collection of material, and a beautiful book which have been written and it is helpful, a reference book even, that is Murugeshan R and Shiva Prasad. So Shiva Prasad, that is an 18th edition of an S-Chen publishing of 2017. You can refer many other books. Thank you one and all.